people might trip on, but that's okay. We're from 4488 Shockwave from Glencoe High School in Hillsborough. I'm Gannon, I'm the electrical lead, and this is going to be my third year being on the team.
I'm Brett Cole, I'm the electrical mentor on the team. I've been on the team for since 13-ish.
I'm Nick Lucas, I'm an alumni of Shockwave. I've been mentoring since 2016.
And yeah, we're here today to talk about some of the wiring techniques that we've learned over the years. And we kind of got into like a set of guidelines and some tricks that we've learned about how to wire and like what works and what doesn't work. And this, this might not apply to everyone, but this is what works and what works for us. And so we split these guidelines or these tricks into three areas, okay? And these 3 areas we call the 3 R's of wiring. It's important to making sure that things aren't breaking during the season so that software development can happen or hardware development can keep happening, like prototyping and all that. It's also important during the competition that you stay reliable, because if you're breaking, then you can't show what your robot actually can do. So reliability is the first R. Repairability is the next one. This is fixing the robot after abuse. This is diagnosing a problem and fixing it in a timely manner. So this is right after reliability, because things will break, and that's just the truth of it. Things break, and so you have to be able to diagnose it and fix it. This is once again important both in the season and during competition, because in the season, like I said, you don't want to be holding everyone up. So the other groups that are trying to get systems implemented. So diagnosing and fixing something quickly is really important. Also really important during a competition, because sometimes you have back-to-back matches, and you might not have enough time to really fix the problem. So being able to diagnose and fix the problem is super important, and especially during playoffs when there is definitely going to be back-to-back matches. The last R is radiance. This is making the robot look good even under abuse. And this is how you gotta do your own play. This is how you make it your own. So when you build your robot, people see, oh, there's that thing's robot, or it's making it your own. So these are the 3 R's of wiring: reliability, repairability, and radiance. So the main goal with these R's is to not have your robot ever looking like that. That's the main goal, is to never have it looking like that. That's the stuff in nightmares for me. It's not good. So when we kind of follow these tricks and we follow these guidelines, we can hopefully avoid that. So the first R, reliability. This is, like I said, wiring it to keep it running during the competition. This is going to be through a full season of use, so you want to make sure that it doesn't. So the first way that we keep it reliable is first by figuring out where everything is going to go. So at the very beginning of the season, after we kind of decide, what the general robot design is going to look like, we ask ourselves, where are these components going? We say, we can preemptively figure out if there's going to be challenges and where things have to go. This was a big challenge last year. Mechanical kept saying, oh, okay, if we finalize the clever design, it's not going to get any bigger. And then it got bigger, and it got bigger. So we had to keep redesigning where we were putting these parts and making sure that we could, prepare ourselves for these problems. Another thing that came up that we were able to preemptively try to solve before it actually became an issue is in 2018 when we had the lift, wires would go way up to the top of the manipulator. This made it so that we had to figure out how to get signal wire that doesn't get messed up from the top back to the rubber reel and keep that signal. And so we were able to see that this was going to be a problem, and we were able to figure out what we could do to solve it. There's also, and simply not just signal wires, but also power wires. They lose power over distance too. That's what this chart is showing. So there's a lot of things to take note of when you're doing that initial component placement in the beginning. Securing connections. This is kind of the main part of reliability. In my eyes, this is making sure that things won't break. So we just keep it simple and straightforward with the zip ties, tape, and hot glue. zip tying things down, hot gluing things. These are all things that you can do to keep the connector secure. We also use another thing, which is 3D printing. We do a lot of, if it's a really important piece, we do a lot of 3D printing to make sure that that piece won't be moved or damaged. You can see this cool 3D printed design for the radio power wire from 1257 Parallel Universe. It's pretty neat. It just keeps it right in there and it won't fall out hopefully. You can see the hot glue on the connector right there. It just keeps it in place and it's definitely not going to fall out. So we know that will be reliable. The radio power. So this is pretty important, and this is a big part of reliability. Is making sure your radio doesn't have to restart, or because then you're basically disabled for a match or part of the match, and that's really bad. So one way that we found that kind of solves this issue, or attempts to address it, is we do two ways we give the power to the radio. This is power over Ethernet, and we use the radio power. So like the normal way. So with these two systems in place, there hopefully one of them, if it does happen, one of them will be a safety net that will hopefully avoid the radio powering down. And the thing is, when you're using both of these, you can just plug them straight into the same VRM circuit because they're both going to the same place, so they can just go to the same place on the VR. The next thing is securing connectors again. This one is about USBs and Ethernet. Ethernet, like the connector parts, are kind of situational because there's a lot of different designs to them. So you have to kind of address each one and what might happen. We got burned on one year. There was a connector where the plastic bit ended up pushing the connector out of the radio, so we were having radio connectivity issues. And once we found that out, then we cut off the plastic part that kept happening. So each one's kind of situational. In this picture, you can see that black tab right there, that actually can go underneath the plastic tab that you use to push it in or pull it out. It can go underneath, and in a way it locks it, so that it will keep it in there. Another thing we do to keep our USB connectors secure is we put tape on the three sides, so it still makes contact, but it's also much more secure because then it's in the connector much more firm. Another way so there's a lot of types of connectors. So each one is kind of on what the connector looks like, or it's kind of it kind of depends. So one way that we address the power poles is we put paper on them. We also do this with PWM. You can see it on the GAN connections right there. We just take them up so that they are less likely to fall apart. And then another thing we do with the power poles is when there's a big subsystem that has a lot of motors, we key them and we put them in big blocks so that they all slide together so that they're much less likely to fall apart. Finally, a new thing that we found about last year is PWM clips that just go around it. They're pretty cheap and we didn't really use them that much, but they're still pretty neat. It's something worth looking into. We use a lot of PWM. So when you're securing these connectors, this picture is of a wire and a chain, and it's because they didn't secure their wires, and it made it so that they weren't reliable because the wire got caught in the chain. So when you're securing these wires down, it's really important to address high risk areas where there's going to be a lot of moving parts or a spot where wires could get damaged. It's an important area to address. Batteries, some teams are, there could be problems that arise with batteries, and we just follow our formula, and we just make sure that the terminals just have the right connectors on them, the right bolt, the right nut, everything's the same and correct on each one, so that we won't run into problems with them. Another cool way, or like a way that we found out how to secure batteries, is this 3D printed part matches the back of the battery. So when the battery sits in it, it can't move left or right. And then just with a simple strap, we just strap over it, and the battery is not going to fall out at all. Because the battery falls out, and that's going to be a disable, or the battery just kind of like rip out of your robot and it won't work anymore, So having like a simple and pretty cheap method to just keep the battery secure, and it works really well for us. So that's another thing to take note of when you're trying to make a reliable robot. Okay, so ferrules. We heard some teams were like having issues with them. Like some people, it's either like people really like them or people really dislike them. And this is what we found to make frills work for us. I think I really like the frills, and I think they work really well. And so what we kind of come up with is this method for having them work. Is first off, you're gonna want to crimp like 2/3 of it, and this leaves a tiny bit, that little metal part right there that's not crimped, will keep the stability of the barrel so that it won't snap off in the connector. And then the next thing that we do is we cut off the first nub, and then this makes it short enough so that the plastic right here fits right to the plastic on the component, so that it's not gonna be sticking out and where it's gonna be less likely to be damaged. This might be kind of situational though, because our fiddles are you can buy shorter ones, so then you might not have to go through this step. But we have longer ones, so we just cut off the first nub and then we fit it fine. Checklist. This is another way to stay reliable at competition. These are super important, and I really think that it's a great method to making sure that everything's working properly. So like I said, checklists identify areas where you think damage could occur to wires. And especially they address high-risk areas, like I said. So these wires that are moving right next to the piston that is also moving, that's a definite high-risk area, and something to take note of each time you come back from a match, from the practice field, or from a practice match. These are also high-risk areas. That black bar right there actually moves up and down. So those motor wires really need to be taken note of each time we use that system to make sure that no damage occurs to us. You can see one of our checklists. This was from 2018. This just goes to each subsystem and looks at each spot where damage could occur to the wires. And we just run through, and we have the spreadsheet printed out at competition. We just run through and check off everything, make sure everything's fine, and that no damage has occurred. This was a checklist from 2015, I think, and it's pretty simple, but it still worked. It still achieved the same purpose, and it's a checklist, and I think checklists are a great way to stay reliable. Repairability.
So here's the next part, which is repairability. So, as Gannon said, right, even when you make it super reliable, things are going to break. Even if it isn't the electrical system that's going to break, the mechanical parts are going to break, and you still have to take things apart and be able to swap things, put it back together, and things like that. So, it's important to make things repairable. So, I think our biggest trick for making it easy to repair is when you pre-assemble spares, when you wire things up, whatever, we put in a very standard length of pigtail, like on the motors, or when we are going to use a particular sensor, we will just make sure to have a particular length of the identical connector and have spares pre-wired up exactly as we use one with the exact same length. Because when we didn't do this back before, right, we would run into these problems. They're like, oh yeah, we have a spare motor here, quick, get it. Oh, oops, the connectors are 1 inch shorter, so that means nothing fits, and it was bad. So, we have, in fact, hand-running example if you want to see. But this is, you can leave it up here and you can come see it if you want at the end. But this is like the way we wire up 775s. We use a lot of 775s. We have a very specific length pigtail. We always end up making them the same length so that whenever you swap out one on a robot, you know exactly how it's wired. The other key piece that we didn't do originally is the orientation of the wires, the polarity. Which you think, oh, on motors, polarity doesn't matter. You just it goes off its direction, everything's fine, it's you burn it out. That's true. But if you're in a hurry, you slam your motor in there, you power it on, the robot tries to zero itself, and it smashes the arm the opposite direction, breaking gears, shredding teeth off. Ask me why. So it's important to make it go the right way. So one of our other things that for repairability is that we talked about we used to use a lot of PWM connectors. All of our sensors were on 3 or 4 pin housing PWM type connectors, which are great, except that they fall apart really easy, which means then you have tape around it. Well, now you're in a hurry and you're fighting with this stupid electrical tape. You can't peel it up, and then now you got to put it back on. So we found these. It's a Molex brand, and the style is Ditto, and they have 2, 3, 4, 5 pin housings, and they are genderless. So now no longer do you have to worry about, oh, this sensor was wired up for this robot 2 years ago, but it had this polarity. Now it's got male, now it's got female, and now cut that one off and crimp a bunch of connectors. It's like they're all the same. It doesn't matter which male or female. And then they have positive locking mechanism on it. So when you're going to replace it, you just hold it. There's little clips on it. We have some examples here. Hand going around. You can just put it together, and then you push the little buttons, the little tabs, and pull it apart. And it's very simple to use. Makes it really fast, but it's secure when you connect it together, and you can pull it apart really fast. So that's what we use for all of our sensors now. We use these mullets for those. Another thing with repairability is you get in the midst of something, and somebody's like, "Oh, I think this sensor is broken. I don't know what do you do." So you have to go unplug stuff, and then you have to remember which one was what. And you get these huge wire bundles. At least we always end up with massive wire bundles, so you have a bunch of sensors and things. It's a big massive wire. The only way to keep it straight is to label things. We have in the past we got a label maker. We printed out big, long, detailed, 7-word sentences about what it is, and those things they never stick. You can't get them to stick on them. You end up like pulling it out and you realize that the label fell off. You don't know where it is. So what we do now is we just get numbers and we label everything with little numbers. And then we keep a Google Docs spreadsheet with all the numbers for all the different connectors and where they went, where they connect to our mode ends, so that when you have a big wire bundle, you're like, oh, maybe it's this one, and then you can actually tell which one it is, which one it goes to. Here's a kind of close up of what I'm doing. And it also turned out to be super useful for the programming group, because the programming group wants to know, well, which PCM do I trigger in order to activate the horizontal movement thingy? And now they can just look up the spreadsheet we've been updating every time we have to change something or relabel it or whatever. And anybody can access it. If you have to, hopefully you never have to do this, but if you ever have to say, oh, the rubber Leo's bad, I need to swap the rubber Leo. Well, now you've got you can just unplug things and then you can plug it all back in based on the numbering scheme you put on the line. Something else that we discovered is this is called the hinge points, but it's really the last several years. This was our robot from 2016, I think. No, 17. Anyway, it was one of the years. When we built this, we had hinge points here, and the whole top of the robot that dumped all the fuel would pivot back so that you could access all the electrical codes and stuff. It's like neat. Because otherwise you just don't have enough space. And we did the same thing again this last year, right? We saw the robot, but we had this funny turret and all this stuff. It was a really low robot. But in order to be able to get all of the wires and stuff underneath, we actually built the whole thing where you could pull some pins out and then the whole turret table would just pivot off to one side so we could actually access all the wires and the sensors, which was very handy. But it also gets complicated to try to wire up around that. And so our tricks that we've learned is to wire all the wires up around where the hinge point is, make sure the wires go along with a little bit of extra length there, along where the hinge point is, and then up into the new zone. And when you do that, right, then it will actually just hinge and you don't have to go and plug things. For a while, on several of our robots where we did this, we had things where it's like, oh, before you do this, you have to unplug 2 things over here, and invariably you forget to unplug them or whatever, and then it's all dead. So the next thing that we've really discovered is subsystems. So from a mechanical perspective, you always think about, this is the intake, this is the manipulator, this is the shooter, whatever, right? And there are oftentimes you're like, oh, we have a spare intake here. It's like the whole arm with the motor and the thing all pre-built, which is fine. But electrically, you need to think the same subsystem. So what we should have done is we started doing here where it's kind of a mess, but you can see there's a big bundle of cables right here. Well, this big bundle of cables that connected yet another big hinge point. This goes up to the shooter, and it all comes down to here. All of the wires come down right at this one point, and there's a whole pile of connectors in different places all along here for this whole bundle. So you can sit there and run, in like 2 minutes you can unplug everything, and you can just take the whole shooter. And in this particular year, actually, we did that between PNW Championships and Worlds. We wanted to work on the shooter, we wanted to tune the shooter speed and some other things, and so we ended up at the end of PNW Championships, we ended up unplugging this, unbolting the whole thing, and we kept it as part of the holding weight. We kept the shooter out, and then we baggaged that to the Worlds. And it was enabled because we had all these connectors. And this is something that if you didn't think to put it in at the beginning and you figured out later, it's like, oh wow, I really want to be able to pull this mechanism off for whatever reason. Maybe you want to swap out the whole thing or something. You can go back in and just cut the wires, all of this like area, and then crimp on connectors and make the connector space. So another trick that we learned is with these conduit and cable chain things. So this, like for the example, this particular thing with this conduit, this is a split seam conduit, so there's a split on the side of it, but it kind of holds it together. This is a nice way to be able to keep your wires out of harm's way, allow it to be movable. So this, in this particular year, right, this whole thing moved here, and moved up and down, and did a bunch of stuff. So we needed to have this flexible, but it had a bunch of sensors out here. So we had this wire bundle that came down here. And so we put it in this conduit. If you needed to work on any of those wires, you could just pull the conduit off, and then you could have access to the wires. And then you put the conduit back on and keep it protected. So it actually worked pretty well to make things protected and repairable. I forgot to mention this again. If you have questions, you should be ask questions about things too. Anyway, so I mentioned something about that was on this same robot. We had a whole bunch of sensors out here, and in order to minimize the wires that were going there and to deal with noise issues that Gannon mentioned earlier, because we have this 15-foot cable running all the way from the top. What we ended up doing is running one USB cable, which has a bunch of shielding on it and some differential pairs and a bunch of other techie terms. So it was a nice shielded connection. And then we put an Arduino up here to be a sensor hub, like we called it. So all of the sensors, we had a whole bunch of infrared distance sensors and some Hall effects and a few other things out here. All of those sensors that were out here on the manipulator fed into this Arduino, and then the Rio would go pull the Arduino for any information from the sensors that way. So that was kind of a nice thing. It made it a little bit more repairable because now you had the sensors, all the wires were real nice and sharp, they were really close here, and you only had the one connection that you fix. It also gives you one side of failure. Oh, now it's time for radiance.
So radiance is where you get to finally have fun if you didn't have fun previously. Radiance is about making the robot look unique from a distance, not just mechanically but electrically. And one of the big things we do with our LEDs, which we'll get to later, that really makes the robot stand out away from the distance where everybody's sitting at the top of Oregon City and down at the time field. But where we start is with custom wires. We use this stuff called silicon wire. More than anything though, it's the strand count that matters. It's what we have like 1,000 strand count wires. So very nice and massive wires here. So this is kind of the traditional zip wire that a lot of people use. It's cheap, it comes on big rolls, but you can see it's very rigid if you've never worked with it before. The silicon wire is like a wet noodle. It's very flexible, it moves wherever you want to go, but the only downside is it does need to be secured more often than not. You guys want to pass that around. The next thing that Gannon talked about is ferrules. Ferrules not only make connections more secure, they also add a niceness to the look. We have a VRM here with some ferrules in it that's also taken up here on wireless. We'll go ahead and pass that around so you can see how nice they really look in there. There's no chance of stray wires coming out, which adds to the reliability of stray wires coming out of one VRM slot and then going right up the ground and shorting right the VRM, which is what happened in this VRM.
So as far as wiring techniques, that's what not to do. Just throw away your stuff in the bucket.
Usually say no, as we do. So the last big thing are our custom data cables, which I don't see factories here. Yeah, you can look. So the data cables are the cables you plug into the top of your SRX for now. I believe the Spark Max is on the same pin out. What we do is we buy just both of the data cable and connectors. We'll put the connector onto one end so it can plug into the motor controller, and then we meticulously, with an exact knife, separate all, 10 wires, and cut away the ones we don't need, and then strip back the ones we need, and solder on our wire to them. So this one right here has the encoder broken out on it, and one of the forward limits that the encoder has for its internal, for the motor controller has for its internal PID. And if you guys have ever used this, you go spend like $10 on this big little blocky module you saw your wires onto, you heat shrink it, and it's just this big ugly wart sitting in the middle of your system. Where this is just a nice clean transition, it is also cheaper to go buy little cable connectors and do it yourself instead of spending it's like $10 on this bring afterwards. And the next thing is, while you're trying to make it look beautiful, you do need to build in flexibility for when inevitably a connector fails and you have to cut it off, and you put the new connector on, and it fails again, and you have to cut it off. And you keep doing that until you finally get it right. So what we do is we add 1 to 2 inches extra on all our wire runs, and that just allows us to, if like something gets caught or somebody said, Dan said earlier with the mechanical kept changing our flag mods last year, so at one time the motor controller was here, but now the motor controller has to be over here. And if it weren't for that extra wire length, we would not be able to just easily pick the controller up and move it. We would have to pull that wire out and fish new wire through what is already a very complex mess of wires down below the factory's real wire. And that brings us next to keeping organized. We create like main value channels, like a freeway kind of. So you have like your side streets feed into the all your motor controllers and sensors feed into the main highway channel going down. The middle of the robot, the side of the robot, sorts the robo reel. Like you can see right here, we have a bundle that comes up along the robo reel. Everything stop off and it's going, and then everything comes off the robo reel and then jumps into the freeway and comes off onto wherever it's going. And then lastly, if all the wires where they belong, we have our cam wire here. We leave about 6 inches of cam wire on each motor controller, so we cut it and cut off about half of what comes on them. Because of inevitable connector failures, we then bundle that up and then just use some double-sided tape and just tape it down to the top of the motor controller. So you can easily find it when you inevitably can have problems with the CAN bus, or maybe we're the only people who have problems with the CAN bus, and that's just us. And one of the big things is nice routing and clean routing does not equal money. I also previously mentored Team 4057 down at Klamath Falls, and this is the robot I worked with them on. We wanted it to look like an engine, so we kind of like separate the motor controllers on each side. And you can see the wires kind of come out and go in along those 2 main routing channels with a couple of zip ties. Other than that, the motor controllers are just double-sided tape down to the board. Super simple, super easy. As long as you plan ahead, you can create something like that really simply. Another big thing is planning your routing channels. Like I said, create those freeways. But don't forget that all your motor controllers have an inch or 2 of wire that needs to come off that can't just take a sharp 90-degree turn immediately. And you can jump into the freeway and go on its way. And that's what we do, is we do like drawing out on our base plate, or we initially start with cardboard cutouts of all the components we're using, and then on like butcher paper, draw out our electrical board roughly. And we just start putting components everywhere where they fit, take a picture of it, clean the board, and then we put components on again in different places and see what looks best and where it fits nicely. It's not a quick process, but it is definitely something that will save you a lot of time and pain in the future when you realize, oh shoot, this motor controller is actually sitting in a PDP, so we didn't plan ahead for that. Another big thing is CADing. Not only does the CADing help you see the layout more physically in 3D and where those wires have to come out and bend, it's also really good when working with mechanical, because they now know the vertical space that you're taking up on with all your connections, all your components, And this has saved us a few times in previous years where a mechanical says, hey, we want to put this thing here, but because your battery's there, we've given you 2 millimeters of clearance between a spinning shaft and the battery. But if it weren't for them knowing that the battery was there, they would have put the shaft into the battery, and then that would cause problems in week 6 when we put it all together and realized, whoops. And then going on to the I/O mapping where everything's plugged in, we also have created in the past this kind of wire diagram of everything plugged into all of the components, just block components. And it's nice to be able to look at and see, we kind of route them like the wire channels would be. And while you may not reference it a lot more than compared to the I/O map, it's definitely a really cool thing to show judges and inspectors, especially when an inspector has a question like, this wire comes into this bundle, and you just want me to believe that it comes out over here, out this other bundle, and goes into the robo video. This is how you can help prove to them that it really does go there. And another big thing that we recently changed is how we do pneumatics. But previously, who here used pneumatics on the robot? Who here uses these big bulky gauges with big tanks and big dump valves? So we used to use those too, and they're great, they're cheap, and they do the job. But once you start adding more and more stuff into the robot, things start getting more and more complex, and you have less and less space. So we started buying these SMC solenoids and manifold breakouts. You can pick these up on Vex. I think AndyMark also has them. So this is 2 solenoids that are the same throughput as most like the kit-apart solenoids everybody has. And this manifold holds up to 4. You can get ones that hold 6 and 8 solenoids. And then all the hoses come to this one central point. So if you ever have a leak, you come to this one point and find your leak. If you know it's near the manifold where it breaks out, otherwise you're digging around it components. This around. Sure. Okay. Be careful. Yeah, they're kind of expensive. Oh yeah. So another thing is these gauges here for our working and stored pressure, along with regulating. This is it. It's just this tiny little thing. It plugs in the line. These are nitro from Automation Direct. Another thing with the solenoids is a lot of companies use them in industrial applications. And you can find them from like electronics and like scrap shops. We bought like 90 of them for $80. And they're all used, but they're used in a controlled environment on FRC where you're bashing against everything every 5 minutes. So that's one, like, they're also easy to find. That's one of the big reasons why we started using them on top of how small they are. And then lastly, coming back to cleanliness and adding to your radiance is bundling everything. So here's that big channel that we've been talking about this entire time, wires in your freeway. Another thing is if you can, drill like a 1.5 by 1.5 inch hole in the side of like a pillar, like your 2 by 1, and run your wires in the pneumatics of it. So here's some pneumatics and some sensor wires going up the tube. They go with the tube. They disappear from everybody's vision, so now it's just the wire, the tube at the bottom, now at the top. It looks super clean. It keeps them out of the way of other robots coming in and grabbing something and running out. I think we've all seen that before. It's unfortunate, and it does happen. And this really does help protect from that. And another thing, we haven't had too many problems. Well, I guess we have this problem in the tall unit, 17, that was powered up with tall lift, and why we had to use the USB for the sensor hub is because the power wires generate a lot of electromagnetic noise that in turn come and affect all your signal wires, especially analog, which is what we were trying to send up and down 15 feet of wire right next to power wires. So if you can separate your power and signal wires, for the most part though, we haven't really encountered many problems. If you're super worried, if you run power and signal perpendicularly, the electromagnetic fields don't interfere with each other. That doesn't make sense. It's a whole physics thing, don't worry about it. You'll learn that in college. And lastly is adding your own flair. This is where we have fun with our LEDs. We have Kryptonite here with their iconic underglow, Bomb Squad with their iconic pillar LEDs, and occasionally their skirt LED. Well, I guess their skirt LEDs got moved up to the crown LEDs. And we have 350 Center High Techers. Did this LED board a few years ago. And as long as you keep, you can, as long as you don't make it too flashy, you can make the robot look really nice. And then especially for people who've been sitting at the top of the bleachers in Oregon City, the LEDs will help you stand out. Especially if you don't have the money to paint your robot, you can easily throw some LEDs on, and that makes you help you stand out from what you see of other boxy, square, single robots. And not only does that help people in scouting know which robot they're looking at so they don't forget or lose you in the crowd. It also, like, people will come and ask you about the LEDs. We get a lot of questions about our LEDs constantly. How do you do them? What do I need to buy? And that brings me to my last thing. I'm teaching an LED class on how we do our LEDs in this room in like 15 minutes, right after this. So if you have any questions about LEDs, and you're not sticking around for the class, go ahead and ask them. And if not, you can save them for that class. And it's just like, it really brings the robot together. It takes you from a really cool robot and just pushes you that one little step further to a very cool and unique standout robot. And with that, we have like 20 minutes for questions. Or 10, depending on if you probably leave a little early.
Do you have any recommendations on how to label the wires so you can still read labels?
Yeah, so we did. I don't think we have anything like
So we brought the Swerve Pod here, which is our summer project, because it's sort of labeled them. But we have these little just number strips that we use. It's not one of the slides. But we put number strips on the locations. Yeah, it's just basic numbers, so sometimes it's not super meaningful, but you can look it up.
And you can purchase those from wiring places.
Yeah,
They're for wiring labeling in the industry.
yeah. I think we probably bought it from Amazon.
Amazon is true.
They're just these little strips that we come up with. You can like we put them on components, so that's their number. Sometimes we cut them down to make it look a little bit nicer. And then when you don't want to just place it straight on a flat surface, you just wrap it on the wire a couple times. And then you can just keep stacking them next to each other and create whatever you want.
So, and then Bruce mentioned that you take into account the wiring as for all the components and definitely layout. We've done that quite a bit. But when you get to that point where you've got this big umbilical that you've created, and now you've got to route it up around a hinge or some other mechanism, are you accounting for that as well in your CAD for that cross-sectional area rather than just a top-down footprint? Or do you kind of just mind at the start of that sometimes?
We try to account for it, but often when we're originally setting things up, you don't know what's coming. So like last year, I talked about how we had the whole turret table pivoted away and stuff. When we first designed that, we had the climber was this big and the turret was this high, and then so we were just going to reach in to do all of our wiring, and we had no need for this pivot thing. And it's just like, oh, the climber kept getting bigger, and the turret table kept getting lower in the design, and then next thing you know, there's like no space at all. So that's when we needed to add it. But by that time, we'd already done a bunch of the other CAD work and design pieces around where we thought we could place the components. So then you just got to have to scramble, and that's where for a while we ended up with, okay, we managed to move a bunch of the wires over to one side, so but we still had two critical wires that were only the opening in, and it wasn't until I think it was our first competition where we finally, after like the third time of ripping apart a $50 sensor because we forgot to unplug the cables, we was like, okay, forget it. When we get back, the first thing we do during unbag is to run that wire around the other way. So yeah, we'd like to plan for it, but we don't.
When you do your electrical test, you work with mechanical and facing different components.
So when we do our electrical CAD, we kind of, so like I said, at the beginning of the season, when we kind of have an idea of what our robot might, at least the base of it might look like, we try to talk about, what is going to be our like our board, our electrical board, like where is that gonna go and what is that gonna look like? And we started, like I said, we started putting out some simple component placements and say, this is gonna be, we talked to mechanical, we said, I think this is where we want our board to be, and this is what we're gonna do to lay it out. We propose this idea of how we're gonna place things, and then they come back to us with, oh, we're gonna put a climber in the middle of all those components. So, yeah.
Sometimes climate comes like a week and a half after you finalized everything, and you go back to the drawing board.
Usually there's like 2 or 3 rounds of that, but we just couldn't expect it. So, but yeah, there's a lot of that communication where you're like, okay, we think we need a battery, we're gonna put it here. Oh, oops, we don't have room for a battery, sorry. What's up work without battery? Maybe if you have tips that you didn't see here, you want to share with us because we want to.
I'm just wondering, did anyone use the PWM clips I was talking about?
Yeah, we
Yeah.
have some.
You guys use
They
them?
work really well for all of our CAN buses.
And also for our
We didn't even know about this, like, and now we've got a few because they came with something fun. We tried them out on the summer project robots. So we've got a few on those.
We found that there's like 2 different sizes of them, and the slightly smaller size is really difficult to switch out. So you have to make sure you're buying these slightly larger.
I noticed like Vex sells them to buy the Vex.
Yeah.
Those are the good ones.
Yes.
That's why I sold the picture. I mean, borrowed the picture from Vex with 3 of them.
Look, did anybody knock at the Molex connector down there passing around that wants to see it? You know, it's there when it passes around, so we can get it. I don't know if that ever made it around.
Oh, I see it.
Oh, right over there.
Yeah, it's by sitting right next to the cactus box, probably.
Yeah, I see how those work. They're generators, so the wire sequence. They have extra wire sequence.
Yeah, so
Yes.
we found like as long as you keep like one side is always up when you're pinning it, as long as that you will always do the same. Virus.
Yeah, we've been showing these here a couple of years. Pretty cool. Yeah, this was awesome.
That's
Or
the
was it LED one?
Okay, so so any one can plug into the other one. So like with PWM, you either have to have one side be the female and one side be the male, and then that's the only way you can plug them in. So when you're making wires, and you want to switch them out, it's really important with the PWM. It's really important to know which side is which, because that could be like a mistake that could happen and just take more time when you want to replace things. But with the mods, you can just plug any side into the other one. It doesn't. They're all of them can plug into each other. That's why they're really nice.
Except up here.
basically like if you ever have like pins coming out and then pins go into a connector, that's a gender connector, male and female. Anybody got any good jokes?
Yeah.
Thank you very much.